Okay, I wanted to cover one common task when dealing with point cloud data, and that's to create a raster of that point cloud. So here we're talking about making a DEM, either a digital surface model or a digital terrain model. The digital terrain model requires that you've identified the ground, so I'm going to skip that part now. But we're going to generate a DSM from this tile. So what we do is we select the tile that we want. We go to Tools, Projection, and rasterize. This tool can actually do a couple of other things, including making meshes, hillshades, contour plots, but we're going to make it just do a standard DEM here. When you get a screen like this, the first thing you want to do is you're going to want to update the grid. Step size is the grid resolution, so this is going to be set to whatever your input values are. My input values here are in feet, which is fine. I'm going to leave this at a 1 foot interval here. So we're just going to update the grid. That looks like this. If you have holes in your data, you're going to want to set this to interpolate. Mine was set already, but if you leave this empty, you can see that I've actually got some points over here where there are water features in this data set that aren't showing up. So if we set this to interpolate, we can fill those in. I've also set the direction here to Z. If you find that this is set to X, you're going to get a side view that looks like this. We'll leave these empty for a second. It would look like this, which is kind of a fun way to look at the environment, sort of looking at it crossways. But we'll set it back to Z. We'll interpolate these values. And we've got the cell height set to maximum. So essentially, we're looking at it, again, making a digital surface model. When you want to export this stuff, you're going to export to raster. I want to export heights. We'll hit OK. I'm just going to generate a raster.tiff here. That's done. To bring this back in, all we need to do, we'll hit OK to get out of that menu. All we want to do here is bring this data in. So I'm going to grab my raster that I just made and drop it into a arc scene that I prepared here. One of the things you're going to, I'll skip the pyramids. You'll see that I'm getting a warning about unknown coordinate system. And as a result, if we zoom to this layer, you're going to see that this has been drawn somewhere in the desert. You'll notice that it's not showing up kind of in the middle of the ocean here, so we're not at 0, 0. We tried to, the coordinates are intact, but it doesn't know what the coordinate system is. So if we take the original LiDAR file for that and I drop it in here, sometimes you'll get lucky and that original LiDAR file will have its spatial reference data. In this case, it doesn't, so I'm going to need to add that myself. In this case here, I've brought up an XML file corresponding to this data set. This comes from so sometimes the stuff will be embedded in a header. This is the LAS info for that particular LiDAR tile. You can see that it doesn't actually have any of the coordinate information. So we're going to kind of go back to the original documentation. So this is in Illinois State Plane East using NAD 83 and orthometric heights in US surveyed feet. And as a result, if we want to fix this, then we can define our projection applying this to our raster and our coordinate system. We are going to find in our state plane system NAD 83. Here we go. Here we go. NAD 83 in US feet. And we're going to set this to Illinois East. All right, and now if we zoom in on our data, it's drawn it correctly. exactly where it should be in the middle of decal.